The goal of these interviews is to help people that are studying engineering try to give an insight into what the real world is like. And in order to do that, I wanted to have some interviews with people that are in the industry. So today, I have a dear friend, Ryan Irby. We both interned for the company that she is now actually working at. It's called Whitmore Manufacturing. She's a chemical engineer, and she graduated from Texas Tech University back this May, right?
Yes.
Actually, yeah, this May.
2020.
So fairly new to the job, but you had some experience with the company in our internship. So I wanted to start off the first question basically by asking what your job description is, what do you do in a day, things like that.
Okay. So my job description, job title is process engineer, which is, I would say, what most chemical engineers end up becoming when they graduate and they go into industry. Um, Day in the life, get into work at 8 a.m., get dressed because we have a uniform service, um, sit down, drink some coffee, read your emails that typically your people, your vendors that you're in contact with, send after 5 o'clock, so you don't get to see them unless you're super into answering emails on your personal time. um, and then just kind of following up with projects, troubleshooting issues that go wrong on the plant during daily operations, trending batches. So obviously we're a grease manufacturing company, so we make our greases in batch processes. So it's trending those reactions and those the manufacturing process of that to make sure to see if there's an issue, what went wrong, where it went wrong, so we can prevent that in the future. Um, and then yeah, just honestly, I'm doing a lot of project management right now and the occasional batch trend, but lots of projects like
Yep.
I have to outsource for.
Mm. Tons of good points you just mentioned. The first being your uniform. So why do you have to wear a uniform at Whitmore Manufacturing? Any reason?
Because it's dirty.
How dirty does it get in a day?
Very dirty, like so dirty that you don't want to. Like, actually, you can probably see on my arm right now. I've got grease. um, so dirty, so disgusting. I mean, it's not disgusting. I love it because it's messy, and I feel like I'm working harder when I get dirty. But it's grease, so you know how like you're laying on your car. You'll like put your arm on your the windowsill of your car, and you lift up your car, and there's grease, right? And that's
Yeah.
but every surface you touch has grease on it or some sort of powdery chemical or something on it that is black. It will get everywhere, and it does get everywhere, and you do not want to wash it in your personal washing machine because it will dissolve your seals on your washing machines. So
Mm,
that's why we have a uniform service.
yeah, that's right. So Whitmore has their own like dry cleaning, washing business for their uniforms because you're literally covered head to toe in grease.
Yep.
Chemical manufacturing is a nasty, nasty job,
Mm-hmm.
and we got really dirty at that place
Oh yeah.
every single day. Uniforms, like one
God.
uniform after another,
Yep.
and
It was
so
kind of
that
hard with
was
the interns though
yeah. Go
because we
ahead.
had to make our own clothes.
Yeah,
The
yeah, and
interns
I
this year, the interns
yeah,
this year actually got their uniforms though, so they don't have to worry about it. But
that's nice. They didn't
yeah,
have to
we were
beg for
lucky.
uniforms. That's good. So that was one point that you brought up. The second point was about process engineering. So is that similar to manufacturing engineering? What's your goal with process engineering? What are your I guess what's the engineer's purpose uh, in a plant like this?
So for me, I mean, I believe the point of the process engineer is to be able to look into those batches, seeing the equipment, knowing what equipment like can give us a trend, and where to look throughout the manufacturing process to see where issues can happen. So it's understanding like the recipe, right? So we heat a batch, it needs to go to 400 degrees, right? It's being able to go in there and see like through our trending software, being able to look at that and say, okay, this is when it should have happened. Did it happen? And being able to know where to go to find that answer. And if that requirement didn't get met, why didn't that get met? So it's
Right.
looking at the process of making your batch. If that makes sense.
That does make sense.
Recipe,
Right.
the it's like I would say the recipe of the formulation.
Right.
What
Exactly.
were supposed to be followed? Were they followed? If not, why not? Is it something that happened mechanically wrong, or is it something that happened with personnel? You know,
Right. Right.
figuring that out.
And then, or was it something chemical that was chemically
Right.
wrong as far as
Was it a bad raw material that we got? Exactly.
right, right? Because one thing I do remember about that place is you have these recipes,
Mm-hmm.
and similar to if you're cooking a meal, if there's a ratio of something that's too
Right.
much when it shouldn't be, that can totally ruin a batch.
Right. Mm-hmm.
And there have been
Like
instances, yeah, go
yeah,
ahead.
where you have like expired. I'm thinking like expired baking soda. Like it won't help your cake to rise, or I don't know what baking soda does in a batch, but like if it's expired, it's not going to be as potent as it should be. So understanding that that could have been what was wrong. It's like looking at other batches that are occurring at the same time using the same raw material. Are they having that same issue? And being able to connect all those dots
Right.
to hone in onto the main problem and what is going on.
Mm. And you mentioned cake mixers. Is the is the anatomy of the mixers y'all have at Whitmore similar to that? Because
Similar
mechanically,
to a
and
KitchenAid?
yeah,
Yes, it's a KitchenAid with um, heating capabilities. So I would say like a bread baker. You know what a bread baker is? It's
right.
like you put all the ingredients into the bread baker, it mixes it and it cooks it at the same time. That's what I would say one of our mixers is.
Yeah, guys, I mean, these mixers are huge. They're what, 10, 12 feet, maybe
10,
more?
12 feet, yeah, 40 to 60,000 pounds. You can put 40 to 60,000 pounds of material in it.
Yeah, and it's the anatomy is quite interesting. Sometimes you can get a glimpse because the operators usually pour from the top, right? They're pouring
Mhm.
materials in from the top. You can see the blades spinning around, and it's quite interesting. I remember working on some projects there that were like that. Um, what, out of curiosity, so aside from engineering, are there other occupations there or other people there that are not engineers that you interact with on a daily basis? How does that go?
Oh, yes. So we have a maintenance team that I feel like we work probably the most closely with because I don't have tools. I have my toolbox that I got from my living alone in college that has a screwdriver and a hammer and a tape measure. But I don't have like a drill gun. And sometimes I need to go, like today, I needed to go install a um, like pressure port where I could take a pressure measurement on a vent,
Okay.
but I didn't have a drill.
Right.
So I had to go ask maintenance. I was like, "Hey, y'all have a drill?" They didn't have one either, but um,
Yeah, poor
it,
maintenance doesn't have
yeah.
tools.
Oh man, maintenance. Yeah,
That's an ongoing
it's like
complaint.
only certain people have this tool, and I'm like, can we just get our own? No, apparently not. We can't. But um, so I would say maintenance because if something is like mechanically wrong or like a pump fails or something, it's not going to really be us taking it out of service. We're going to be the ones telling everybody, like, hey, this is having an issue. We're going to do what we can to troubleshoot it without taking it out of service. But if it needs to be taken out of service, we're the ones telling them to, hey, or saying, hey, this needs to be taken apart and cleaned or needs a new freaking, I don't know, something, gearbox or
Yeah,
whatever.
yeah, right, right. Yeah,
Um,
yeah. it's I mean, when it comes to, with Whitmore at least, you are a little bit more hands-on as far as the engineering is concerned. It depends on company to company.
Right.
But right, usually when you're speaking to the maintenance department, they're the ones that are going to be executing what your request is. So you can have discussions and things like that with the maintenance team, but at the end of the day, the engineer makes the final call on what needs to happen, and then your maintenance department executes that. And sometimes if it's something that maintenance doesn't do often, they might even need instruction on that. So you
Right.
might be the ones the engineers might be the ones that are actually writing the instructions on how they want their project to be carried out. There's other things, for example, right? Like when a pump fails for a mixer, that's standard, that's maintenance. They do that all the time. They don't really need a procedure.
Right.
But then there's other things where they do need a procedure.
Right. Like today, and this kind of goes into the trending the batch and things. We're having a batch that took 3 days to cool. And we have cooling mechanisms on this mixer and on this batch where it should not have taken that long.
Right.
So first what we did was trend the batch, compare it to the same batch that was in the same mixer a few days prior to see, did it take that long? No, it didn't. Okay, so let's look at the cooling jacket, right? Cooling jacket was fine this first batch. And then a couple days later, pretty much after our shutdown, when we tried to make the same batch, it didn't work. Our cooling was like oscillating and was not acting like it was prior to the shutdown.
Mm.
So it was actually my boss was like, okay, go vent the cooling fan line. I'm like, okay, I don't know how to do that. Run over to maintenance because they know how to do it because they're the ones that execute that kind of stuff. He walked me up there, he showed me how to do it. And then once that job was done, I mean, that's all I needed. And I was like, okay, that it still didn't fix the problem. Oh, my dog's behind me. And we went back, we looked at the bottom. Oh, we realized that the person who was doing work on our mixer didn't open the valves that they had closed back up. So we
Mm.
didn't have cooling capabilities at all when we were trying to cool the batch. So it was just ambiently cooling for 3 whole days when it should not have been ambiently cooling for 3 days.
Right, right. Sometimes you'll notice that it might not be a machine that failed or something in the process of manufacturing, but
Mm-hmm.
you have operators, you have technicians that are human beings
Right.
that are exhausted,
Mm-hmm.
and sometimes you end up finding out that okay, it was operator error,
Right.
which is quite common. And so you do have to do a little bit of detective work as well, and especially with something like the chemical manufacturing side of things where it's extremely technical in that sense, right? You have to know what's going on with this recipe,
Right.
and so it's definitely something to take into account. There another interesting thing about Whitmore is they also have their own chemist department or chemistry department
Mm-hmm.
where they have chemists. Would you be able to talk a little bit about that, or maybe your interaction with them? Do you interact with them much at all? I know there was good old Man Bun Steve.
Oh yes, Man Bun Steve, he's still there.
Yeah.
He's the best. So the chemists are not genuinely, generally the ones who come to the engineering department, the engineers, when they see that something is going wrong with a batch. So
Mm.
periodically, like usually at the start, the middle, and the end, a sample is taken of each batch and taken to the QC lab where they check it to make sure it has all the right viscosity. So they do like a penetration test where it's like a little pin, right? Almost like a pendulum. And it is like basically dropped into a vat or like a small cup of grease, and it measures the viscosity or the penetration of the grease. So that'll tell us if the grease is too viscous or too non-viscous. I don't know if
Right,
non-viscous
right,
or
right.
too hard or too soft is usually what we say, or too heavy or too soft is usually what we say. Um, so if adjustments, like if they see something's not how it should be with a batch, they'll make an adjustment by adding oil or more thickener or a different raw material to account for that. And if that's still not fixing the problem, they'll call the engineers to trend the batch and see, okay, did everything go as it should have? Did the recipe get followed as it should have? And that's pretty much the closest that I've had to work with the chemistry department.
That makes sense, though. Yeah, that's exactly what you said, right? So you're making product. Periodically, you take a sample of the product, you deliver that to the chemists who check the product via some tests that they have, one of which you mentioned, the penetration test. And then based on their results, find out if this sample is conforming to what they wanted it to be.
Right.
And if it's not, at that point, they contact their engineers to essentially check the process of what's going on. How is this being made? Makes total sense, right?
I'd say another way that I personally interact with the chemists is I'm updating our electronic batch ticket system, which is basically a computerized, like automatic thing that makes things go into the mixer when they need to go into the mixer and makes things turn on in the mixer when they need to turn on, whether it being completely reliant or relying upon operators to start things. Because if we relied upon operators to start things all the time, things can go wrong fast because humans make mistakes. So we have this electronic batch ticket system that follows, like, basically it's word for word what the recipe, what our bill of materials says. Right. So I'm going in and I'm auditing essentially. I'm auditing our bill of materials, and I'm going through our EBT system to make sure everything is. So with this audit, there's like a big change that I'm making is I'm adjusting the RPMs on a batch. So the agitator blades have, I don't know if it would be not variable frequency drive, but the speed and how fast they go is controlled by an RPM, right?
Sure.
So on top.
Yeah.
So I'm ramping up the RPMs at a certain point, but keeping them low at the very beginning. So operators aren't getting splashed by things as they're adding things into the batch.
Right.
So that requires me to contact chemistry to get their approval for me to make that change. So it's tracked through like our MOC process to make sure that the lower RPMs at the beginning and then the higher RPMs at the end isn't going to affect the chemistry of the batch.
Wow.
It doesn't, but it's just another connection that we have with R&D or chemistry.
Right. It seems as though companies are implementing some sort of digital software in their processes to it's quite helpful. So for example, like at my job, we have that as well, where all of our inspections are being our mechanics are inspecting these machines, and they put their findings in an online kind of inspection jacket.
Right.
And then the engineers take a look at it. And I can see that also happening here, right? So even if it's not necessarily the same, they're not inspections per se, but it's digitalizing the process in a way.
Yeah.
And these mixers are quite smart in that sense because they can be controlled via the computer, right?
Right.
Opening valves, shutting valves, things like that, right?
Yes, and it's not every single. I would say 95% of our valves are electronically controlled.
Okay.
What would that be? I guess pneumatically controlled via.
I think pneumatic is saying you're using air, right?
Right.
You're using
valves, but
right.
The pneumatics are controlled by
correct. Yep.
The
PLC.
Yeah.
Yeah, that was something. Controls is not easy, by the way. No. Yeah, to this day, like, the class wasn't easy.
Right.
And even even when your boots on ground, controls is it's tough. Speaking of which, though, as far as not understanding things, or maybe along those lines, what are the challenges, potential challenges you face every day, even if it's not every day, just challenges in your job, things like that.
So I'd say the most challenging thing that I face is not having the answers to the issues that are arising on the plant currently. Um, and I could say, like, I would feel like even the engineer who's been there for like 5 months, 5 or 6 months now, like
Right.
he's still learning as well. Like everything that can possibly go wrong and all of the questions that he could possibly be asked, there's always a new question, right, that an
Yeah.
operator will come and ask, and something, there's always a new alarm that's going to go off, right, that we haven't been there for very long, so we don't know exactly how to go about troubleshooting it, and to go about, okay, can I turn this on and turn it back off, or is the entire plant going to shut down, right? Or is the entire batch going to cool down and I have to wait 2 days for it to get back up? That's I would feel like that's the biggest challenge for me, is understanding, like, I guess kind of like the scope, or like my boundaries of what I can do, what I'm allowed to do to try to troubleshoot something, um, or like what is too far, like can I go and turn off this VFD and restart it? Like what does that affect if I do that? Understanding like what it's all connected to and things like that.
Especially with something as sensitive as the greases that they're so chemically dependent
Mm-hmm.
that turning something off could be the difference between this batch being usable and unusable.
Right.
I think there were a couple times where we had to throw away batches, right?
Oh yeah, that happens all the time.
Yeah, and guys, this is not like a tub. This is
Right.
like 15,000
Yeah,
pounds.
20,000 pounds. Yeah, just because it's
20,000 pounds.
non-conformance and didn't pass QC because of whatever reason. I think we're at what, like, I want to say I don't want to say it's 3 non-conformances a month, but
Mhm.
it's in the range of 0 to 3 every month. So that's up
Right.
to 60,000 pounds of chemicals. Now, that doesn't all just get thrown to burner fuel or whatever. That
Okay.
gets put into rework. So
Okay.
we have a batch that, needs a little extra help, or we can add things to it to use less raw materials, and we'll work in these non-conforming batches into a new batch. That way it is still usable and it's still profitable for us.
Right. Yeah, that's a great point, right? So there's certain times where, let's say, a batch is non-conforming. If it's way too far gone,
Right.
we'll burn it.
Right.
But if it's still usable, we can recycle it and potentially use it for something else.
Right.
Another thing that I wanted to mention about manufacturing process is you always care about non-conformities or non-conforming parts or items.
Mm-hmm.
And it seems that maybe at Whitmore it's 3 per month as the limit, or some sort of range that they have.
Mm-hmm.
And I remember at my first internship that was also the case. There was a certain number of non-conforming products you could have.
Mm-hmm.
I don't know if it's per day or per week or whatever,
Mm-hmm.
but that's always a big deal in manufacturing because these are products that you're making for customers.
Mm-hmm.
And that's another thing that you might be able to go into depth with. You might have a little bit of experience with it, but telling the customer that their product failed.
Right. And now it's going to be another week before we can.
Right.
We have to put your next, like, this batch that we should have had to you today. You have to wait another week because we have all these other customers that are lined up right after your batch, but yours failed. So
Yeah.
it's going to be another a week or another month or whatever. Yeah.
Right. Right. That's definitely a challenge.
Mm-hmm.
So I guess the last question I have is for, what would you tell people who are majoring in chemical engineering, or who have plans of going into this industry, potentially some things that you didn't know while you were doing this? Any words of wisdom in that regard, or anything you feel like you can tell the people that are watching?
I would say it's a lot less chemistry than you think. Like it sounds like it's going to be all like it sounds like you're going to be a chemist. And I went into with the idea, I mean, like especially at graduating high school, I went in with the idea that I'm going to be working with chemicals. And I do, like, but it's not like in the same sense as you had to deal with in like your chemistry classes in college or in high school or anything like that. It's a very basic knowledge of the chemicals that you're working with, but a very large knowledge of the chemical that you're making.
Mm, yeah.
And like how that chemical reacts with things once they are put to you like the use that they need to, like a frac pump grease can't go on this because it's going to eat away at this, like understanding the chemistry of the product, that the end product, not necessarily the raw materials that you're putting into it.
Which makes sense. Yeah, because you're making the you're going to start focusing on the products that y'all make
Right.
as opposed to theoretical chemistry and things like that.
Right.
You have X amount of items that you make,
Mm-hmm.
and you want to know exactly what they're made of and things like that. So your chemistry is being applied in that sense.
Mm-hmm.
But as far as all the theoretical chemistry that you potentially learn,
Right.
you're obviously not going to be applying
Right.
even a fraction
Yeah,
of that.
that's your chemist's job. Which I mean, it's great. It's great to know that. But me personally, I mean, a month and a half in, or nearly 2 months in, I haven't had to really apply it that much.
Yeah, and even you were there for 3 months during the summer too,
Right.
right? And
I mean, I read about it, but
yeah,
it didn't help me with any of the projects or whatever that was going on. It just kind of just that clear liquid on the ground might not be water. It's probably acid. you know, but I mean, yeah.